All right, this one should be pretty short. This is a couple more examples of mean, median, and mode. And I want to go back to that example we did in class the other day with the president's ages, the year that they were first inaugurated. So here it is on the PowerPoint, but I also have that Excel sheet that I had with all of them sorted. So if I can bring that into view here, there it is. So it starts with the highest, 78, goes down to a 42-year-old, 46 presidents, so they're all listed. Right, if I want to find mean, median, and mode, to find the mean, we're going to add them all up. So I'm going to add them all up here, and if you notice, it gives me a lot of stuff down the bottom. It tells me that the sum is 25.55, and then it actually calculates the average for me. The mean age at inauguration was 55.5 years old. Okay, so the mean was 55.5. All right, the median, we're going to have to average the two in the middle, right? Because we've had 46 presidents. So 23 in the top half, 23 in the bottom half. But look what happens when I go to do the average of the two in the middle. They're exactly the same. So the median is just 55. All right, what's the mode? Let's see what the mode is. I'll bet you it's somewhere in the 50s because there's a lot of grades, a lot of ages in the 50s. All right, there's 4 of them that are 57. There were 3 of them that were 56. There are 4 of them that were 55. There are 1, 2, 3, 4, 5, 6 of them that were 54. Okay, so that looks like the one that occurs most often. There are 6 of them that were age 54. So the mode is 54. And that's why I think this is sort of a remarkable set of data because, again, realize that this spans from George Washington, 1787, I guess, when the Constitution was ratified and by all the original 13 colonies, all the way through to current day, 2022. So that's a span of several hundred years. And yet, of all the 46 people who've been elected president, the mean, the median, and the mode of their age at first inauguration is within a year and a half of each other, right? The mode is 54, the median is 55, the mean is 55 and a half. Pretty remarkable for that set of data. All right, here's another example. Suppose you played 8 basketball games. Your last 8 basketball games, you scored the following number of points. Find the mean, the median, and the mode. And I use the word sample mean in here because I'm assuming that you played more than 8 basketball games for the season. So this is not the entire population, right? This is not your entire season's record. This is just in the last 8 basketball games. I took a sample, and that's what's in my sample. So we need mean, median, and mode. So the first thing is, let's add up all these numbers together. 3, 16, 14, 10, 13, 15, and 14. I get 85. So the mean is going to be 85 over 8, right? 85 is the sum of my points. 8 is the number of games I played, so 85 divided by 8 is 10.625. So even if you're adding data that's discrete, you can find a mean that has a decimal. So you're not going to score fractions of points in a game, so really this is discrete data. However, you can find an average that is not an integer. So that's the mean. The median is the one in the middle. Well, I could go through and I could line them up if I want. 16, 15, 14, 14, right? 16, 15, 14, 14. I got a 13, a 10, a 3, and a 0, right? So those are my 8 games. The median, 1, 2, 3, 4. 4 on the top, 4 on the bottom. Even number of data points in this set. So the median is going to be the average of the 2 in the middle. So the median is going to be halfway between 13 and 14, so 13.5. The mode is the one that occurs most often. Well, the only one that repeats in this set is the 14 points. All right, so I wanted to make you an example where the median or the mode is actually the better indicator and the mean is not. Because in general, if I wanted to know what kind of a basketball shooter you were, you score about 13, 14 points a game. One game you only had 3 points, and one game you had no points. So maybe you were injured, you got sick, you were only in for a couple of minutes, or you had a really bad day or a really tough opponent. But other than that, you seem to be a 13, 14-point shooter more than you are a 10.6. So sometimes the mean is not the best indicator because the average can be brought down, in this case, by very low scores. So that 0 and that 3 brought down the average, whereas the median is more resistant. It's more of a resistant measure to those outliers. All right, let's take a look at one more. Suppose 9 students made the following scores on a test. What's the best indicator of their scores? You've got a wide variety of scores on this test, right? And obviously I made this up so that there was like a gulf between the high scores and the low scores. So let's add these up. Right? Take a second, take 30, 35, a couple of 40s, a couple of 92s, a 93, a 98, and a 99. So I get 619 as the sum of the scores. 9 scores. So the mean is a 68.77 repeating. So let's say the mean is 68.8. What's the median? The median is the halfway mark. So we count 4 from the bottom. We count 4 from the top. Oh, look. The one that's right in the middle is a 92. And then the mode is the one that occurs most often. Now, this set is bimodal. Look, there's 2 modes. The 2 modes are 40 and 92. So I've got 3 wildly different measures of center that come from this test scores. I've got wildly different test scores, right? I've got a bunch in the 30s and 40s and a bunch in the 90s. And the 2 modes reflect that, right? They reflect that I got a set of scores in the 40s and a set of scores in the 90s. The median is probably not the best indicator of how the class did in general, because a median score of 92 includes only that high one. Could it be that the mode helps me to see that there's a group of test scores in the 40s and a group of test scores in the 90s? I'll go with that. The mean could be interesting, but you realize nobody got a D on the test, right? 68.8, nobody scored in the 60s. So in this case, the fact that this is bimodal and they're reasonable representations that there were 2 distinct groups of students who got results on this test, one who scored in the 40s and one who scored in the 90s, that's not a bad indicator of how the class did in general, and that indicates that there was a wide difference between them. Now, the next step to go from here would be talking about data displays like box plots, and then getting into what eventually we're going to call standard deviation. So the standard deviation will help me to see how spread out the set of data is. So if the mean was a 68.8, is that because everybody got scores in the 60s and 70s, or is it because of a situation like this where we had a bunch of really low scores and a bunch of really high scores? All right, so that's where we're going to wrap this one up, and then we'll move on to box plots later on.